Well. Hello. Welcome to the third week of the ARP course. So I will reduce myself to a corner. Okay. So, while I'm asking you to read in advance all the slides that I put in our web last week so that we can directly discuss them on Tuesday, I take the opportunity of showing you the central slide. This is the typical slide depicting the fundamentals of our kernel that we are discussing, and we will finish next week in describing all parts of the Unix Linux kernel, and in particular we will discuss the concept of process and how to manage processes, how the system manages processes, how we can, as programmers, we can run a new process, how can then a process communicate with other processes, with the external, and how to synchronize, how to raise and receive events, and so on. This is the slide, and you remember that these are user process in the user space. So the user space, and this is the kernel space. You know that all processes must communicate with the kernel for issuing system calls. System calls can run new processes, can make processes communicate each other, also with daemons. You remember the daemons are processes that carry out some services, and peripherals, and reading, writing, and so on and so forth. So I have the opportunity, I was saying that, to introduce a special process, user process, that is very interesting for us, and we will use widely in this course, and a good system programmer uses widely that process. The process that we are dealing with is the shell. Historical shell. In the lab course, Professor Recchiuto is also describing the shell and how to use, and we do the same. We will do the same with complementary informations. Well, the shell is a process, is a user process, and is the interface, the textual interface with which we communicate to the operating system. Let's open the shell. So it looks like a window, a textual window, no graphics, is old style way of communicating with the operating system. It is the oldest way for communication with the operating system. The oldest in the sense that when Unix was born, this was the only way of communicating with the operating system, and is still in use, in wide use. If we are system programmers, we can use the shell, and it's very efficient to use the shell since it's very fast. And another point that is very interesting for roboticians, who develop software, that the fact that in many systems, many embedded systems, there are no graphical interfaces, no point and click, no graphical user interfaces, and the only way of communicating with the system is just to use the shell. In that case, in any case, the shell is a user process that waits for commands in general. In systems in which there are no graphical interfaces, the shell is run at boot time, so you directly interface the system in a text mode. But in any case, the shell is your process. What we can do with the shell? Many things. We can issue commands. The simplest command is ls, just listing the content of the current directory, or in long format, -l, that means okay, that's wrong command. Okay, that's in long format. You will learn basic commands. There are tens of commands that the shell is able to interpret and immediately execute. Well, I have to warn you that the shell is not a simple interpreter of single commands. It's just an interpreter for script languages, a script language that is simply called the shell language, that is similar to C language and is able to manage simple data structure, simple data, but also processes and system calls and so on. So, as a matter of fact, when you issue a single command like ls, just listing the directory, or show me which is the complete path of the directory I'm accessing, like print working directory, simple commands, is just a simple example of statement, of single line statement that the shell is executed on the fly. But you can also write programs in shell with the control loops, with the data structures, arrays, and a number of things. We don't do it now. I will show you some examples later in a successive, let's call tutorial. So why we are using the shell? Because all the simple programs that we will use and you will write yourself solving problems at the low level of POSIX standard interprocess communication and writing concurrent programs in POSIX, you're asked to use directly the shell. There are no useful or efficient graphic user interfaces like Visual Studios or something like that to do that. You must do here in the shell. For example, I think I have I have the hello.c classical program, so we can compile gcc hello. A useful hint is that when you mention a file, if you press tab, the shell tries to complete the name. If there are ambiguities, stops and shows you all the different files whose name at the prefix that you're writing. So just he, nothing, does only this file. So it's a programmer usually does that because it's very, very fast. So you compile. You have compiled, and the standard output of the compile, so the default output is a file that is called a.out. A.out, if you don't mention any other name, a.out is the output, what is generated by the compiler and linker. You can rename for example, with another command that is move, like rename, move a.out, just a dot, and it's completed in hello, and now in the directory there is hello. We can run hello simply, and that's a basic rule of the shell, is just mentioning the name of an executable file, and so it is run. So it's the simplest way of running a new process in the operating system. The shell does. The new process is the executable hello. To do that, it's strange, but you will learn very fast that you must say ./hello. That means hello in that directory. Dot is the name, the conventional name of the working directory. You must do that because otherwise it seeks for hello everywhere in the file system. And so pushing, we have the answer hello world, because we can, the command less is very common to have a printout on the screen of a text file. It's very simple. Include stdio.h in its main with printf hello world. Q for exiting. So I've also shown the basic command of the shell. So you must take in high consideration, strong consideration, the shell. Oh, well, in this case it's called the BA shell, the bash. There are several Unix like or Linux shells. From our point of view, we cannot distinguish when there are little differences. So we call it simply shell. So the shell is a way of communicating with the operating system in a textual form. It's the only reasonable way of doing system programming, so using the POSIX standard. But at the same time, from a didactical point of view, it's very interesting because the shell is a process, and we will show, using the shell process, all the principles of that are characteristics of the processes in a concurrent POSIX program, as to say inter-process communication, activating new process, raising events they are called in Unix signals, receiving events, establishing communications, and so on. And so it in itself is a demonstration on how concurrent programming can be done in POSIX, since the shell is one process able to support concurrency. We will show. I don't want here just to describe all commands, all useful commands of the shell. And this is not a tutorial on this. I will do. In Aula Web, you will find a first document with the list of the top commands, top useful commands for the shell, frequently used commands, including listing ls, or print pwd, the print working directory, and so on. Several commands, and I will illustrate, and we will use them in doing exercises. So but keep your attention on the fact that the shell is just a process that you run, or that the operating system runs at login time if you don't have the graphical interface. and you can use shell commands to implement almost all POSIX primitives for concurrency that we will describe in detail for using them in C language program, or as to say in C language processes. Just an example, let me stay aside. Just to clear, oh sorry, just clears the windows. There is a, if you want to know the amount of processes running in the something went wrong, but I think that everything now works properly. If we want to know the amount of processes running in the operating system, we have just watched them in another video. We have a command that is PS, the process status, and with argument, in particular this one, and we are asking the operating system to show all processes, and you see a lot of processes, many screens. So the output, you see hundreds of processes, and at the end you can see the PS process that we run for, that produces this output, the PS itself, with the I am the owner of that process. You will know this concept, and other information, the process ID and so on. And typical of the shell, the last concept for this video is that you can run another process together with the PS. So when I wrote PS, I just asked the operating system to run the process, the program, the executable program PS with such arguments, instructed it to showing or to printing what we have seen. But I can also run simultaneously, concurrently, another program asking the first one, PS, to instead of outputting the printout on the window, to send the output data as input data to the second process. And the second process, and so there is a syntax that you will learn very quickly because it's very simple. There is a vertical bar that is called pipe, a tube, the same name of the POSIX primitive to make two processes to communicate. Pipe, we will see. And so the shell executes directly generates the pipe and connects the first process, PS, using a POSIX pipe. There is a communication channel of the type send receive data, and connects in input to the second process that is less. Less is able to distribute the output in single pages instead of having just one only printout in this case. So we see here, and pushing the bar, the space bar, we can go on one page and so on and so forth. And this is it seems simply having asked to printing in separate pages, but it's not true. Is a more interesting concept. we have just run 2 processes, so the shell was able to generate 2 processes. The one thing that we will learn next week, 2 processes, and connecting the output of the first process to the input of the second process. So establishing an inter-process communication. It's just an example to show how important it is to understand and all the characteristics of the shell as an interface, because it includes all the inter-process communication that we will learn for using them directly in the compiled code. So I remind you to read all the slides before we have the class, and we'll meet on Tuesday. Okay, bye-bye, and thank you.